Hello students, I am Rajni Verma and today I am going to start force and Newton's laws of motion. In our previous lessons we have studied motion but we did not study about the cause of the motion. When we look around us, we see that all objects, bodies or people are either at rest or in motion. There are so many things happening and so many changes taking place around us. For example, an object at rest is set in motion. A moving object changes its direction. The speed of an object increases or decreases. A moving object comes to rest. The position of an object changes. The shape of an object changes. And all these changes are due to a push, pull, twisting, shifting, compressing, or stretching. So what causes all these changes? The cause of all these changes is a force. In your previous classes, you learned that a force is a push or a pull. Now we shall go in some more detail. A force is produced due to interaction between objects. In physics, the word interaction between two objects means that the objects produce an effect on each other. Actually, the word interaction means mutual action. So, in physics, interaction between two objects means that the objects produce an effect on each other. A force can change the position, velocity, shape of an object, either any one of them or more than one. By change of position, we mean there is a motion produced in the object. This position may change either in continuous motion or by shifting the object. Then the velocity. The change in velocity means there is a change in either the magnitude of the velocity, that is the speed, or there is a change in direction of the object. So this may change the velocity of the object in either of the way. Either the magnitude or the speed change or the direction change, or in some cases both may change. The shape of an object may also change. The shape of an object may also change by application of some force. But since we are going to study Newton's laws of motion, we are interested here only about the changes in the position and the velocity and not in the change of the shape of an object. A force cannot be seen, tested or heard or can be measured directly. We can know about a force only due to its effect on an object. A force is known by its effect only. It is a physical quantity and its effect changes with direction. So force is also a vector quantity. It has both a magnitude and a direction. Just like when an object moves, we say that a body is in motion. About force, we say that a force acts on a body, a force is exerted on a body, a force is applied on a body, a force comes into play. Now, there are two things to be kept in mind. A force is applied by someone on someone. So, there are two agents here. Someone who applies the force and something or someone on which the force is being applied. When we look around us, we observe mainly two types of forces in nature. They are contact forces and non-contact or acting at a distance forces. By contact forces, we mean those forces which come into play when two objects are in direct contact with each other. That means they touch each other. Examples of such forces are push, pull, frictional forces, pressure, tension in a string, etc. And non-contact or acting at a distance forces are those forces which act even when the objects are not in direct contact with each other or they do not touch each other. These forces act from a distance as well. These forces are gravitational force, magnetic force, and electrostatic force, etc. Although there are four types of fundamental forces in nature, we are not going to study about all those. We will study only about those forces which obey Newton's laws of motion. Although force is a physical quantity, it cannot be measured directly. It can be described only by its effect on the object on which it acts. The effect of a force depends on its magnitude, its direction, and the point of application. By magnitude, we mean how large or how small the force is. By direction, we mean in which direction the force is applied on the same object. And the point of application means at which point exactly the force is applied. And all these three are equally important, and the effect of the force changes due to change or variation in any of these three. So let us take an example. Let us consider this block. It is a cuboid and it may represent a block, either a wooden block or a metal or anything. So if we apply a force on it, let us see what happens when the force is applied on different directions. In order to understand the force or the nature of the force completely, let us take a practical example. Here I have taken a cuboid. As you can see, it is a packet. Now suppose I apply a force from this direction. So the object or the block will move in this direction. If I apply the force from this direction, it will move in this direction. And suppose this force acts on the object so that it moves, and I apply another force from the opposite side, what happens? The movement stops. Similarly, if I push this object and all of a sudden I stop pushing it or I withdraw the force, what happens then? Again it stops. So the force here is necessary to produce the motion. Larger the force, larger will be the speed of the object. Now about direction. As you have seen, if I push the object from left, it moves towards right. If I push it from right, it moves towards left. Similarly, if I push it from this side, it will move to another side. Now, the point of application. This is also very important. Let us see, if I push the object at center slowly so that it does not change its direction, we see that it can move directly in the opposite direction. Now, if I apply the force here at this corner, it rotates in this direction. What happens if I apply the force along this point? Now we can see that it rotates in the opposite direction. So we see that the magnitude of the force, the direction of the force, and the point of application of the force all describe the force completely. The effect of a force depends on these three quantities: the magnitude of the force, the direction of the force, and the point of application of the force. Now we shall learn about balanced and unbalanced forces. But before we discuss the effect of forces, let us recall what we had studied in the chapter of motion about acceleration. As we had seen, acceleration is nothing but the change in velocity. This change in velocity may appear due to either the change in the magnitude of the velocity, that is, the change in speed, or the change in direction. Here, when we are going to study the laws of motion, we are not going to study the effect a force produces in the shape of an object. So we are concerned only with the acceleration or the motion of an object. So when we say a change in acceleration, or when an acceleration is produced, it means that there is a change in the motion. Either a body at rest starts to be in motion, or it stops, or there is a change in its direction. Either the speed increases or the speed decreases. So the effect of the force may be described as the production of an acceleration. Whether an acceleration is produced or not, that will be the effect of the force. As we saw in this example, if there is a force acting on the object from one side and there is another force, suppose from the opposite direction, which stops it, what happens then? The forces are said to be balanced. That means although there are two forces acting from opposite sides, the object does not move. But suppose all of a sudden one of the forces is removed, what happens then? The object moved in the direction force which was still acting. So we see that now the forces were not balanced. In this case, the forces are balanced when the two forces are acting from opposite direction, but still the object does not move. Now one of the forces is suddenly removed. What happened? The object almost flew. And if there is no change in the motion of the object, or there is no acceleration produced, then we say that the forces are balanced. Otherwise, if there is a change in the motion of the object, or if there is an acceleration produced, then the forces are said to be unbalanced forces. So we can now define the balanced and unbalanced forces. Although I have shown you with example with only two forces, there may be more than two forces acting on the object. What happens in such cases? Let us see. Suppose here is an object and a force, say F1, acts from this left direction. Then the object will move towards right. Now suppose there is a force acting from right, and that is F2. What will happen? The object will move towards left. Now suppose we look at the same diagram with two forces. Suppose there is another force F2 acting from the opposite direction. What happens then? There may be three possibilities. Either the object will move towards right, and that will happen when F1 is greater than F2. Then the object will move in this direction. The second case may be when F1 is less than F2. What will happen? The object will move in this direction towards left, or in the direction of F2. And the third case may be when the object does not move at all. It remains at rest, and that happens only when F1 is equal to F2. And in such case, we say that the forces F1 and F2 have balanced each other. Now this is the simplest case when F1 and F2 are two forces acting along the same line, along the same perpendicular direction to the object, and there are only two forces. But there may be more than two forces, and then the situation will change. So here we have seen that the forces may be balanced. In this case, the forces are balanced, and in these two cases, the forces are unbalanced. So we can say that two or more forces acting on an object are said to be balanced if they produce zero acceleration. Two or more forces acting on an object are said to be unbalanced forces if they produce some acceleration, that is some non-zero acceleration in the object. Here again, keep in mind that when we say an acceleration is produced, we mean to say that there is a change in velocity. Either the velocity may be zero or it may be some quantity, it may have some magnitude, but in all the cases, if there is a change in velocity, then we say that there is an acceleration produced. Again, the change in velocity can also mean that the speed remains constant, but there is a change in direction. So all the cases are covered in this statement when we say there is an acceleration produced or an acceleration is not produced. So now we can write the definitions of balanced and unbalanced forces. If two or more forces acting on an object produce zero acceleration in it, they are called balanced forces. On the other hand, if two or more forces acting on an object produce a non-zero acceleration in it, they are called unbalanced forces. So we saw that when the forces are balanced, there is no effect of the forces, although there are two or more forces acting on it. But what happens when the forces are unbalanced? Suppose two or more forces are acting on the object and they produce a non-zero acceleration in it. What happens then? Will there be any effect of the forces on the object? And if there is the effect produced in it, what will be its nature, or how can we find out what will be the effect of these forces? Suppose there are several forces acting on an object. F1, F2, this is say F3, F4, suppose F5, and the overall effect of these forces is that the force moves in the direction, say in this direction. Now let us take another case when there is a single force acting on the same object. Sorry, this does not look as the same object, but suppose this is the same object. If there is a single force F acting on this object and it produces the same effect, the same movement or the same acceleration on this object, then this single force is equivalent to all these forces acting together. So we can substitute this force F in place of all these forces taken together. Such a single force is called the net force or the resultant force. So now let us define this net force. So now we define net force. A single force which, acting on an object, produces the same acceleration as produced by two or more forces acting together on the same object is called the net force or the resultant force. The net force cannot be calculated by simple maths. We use vector algebra for such calculations. Vector algebra is a separate branch of mathematics which is used to add or subtract or to find the resultant of vector quantities. So now we know about the balanced forces, the unbalanced forces, and also about the net force. So as we have seen, a force has magnitude and direction. Therefore, it is a vector quantity. A force is a vector quantity. So students, in this video, we discussed forces, types of forces, nature of forces, and how we can describe a force completely by its magnitude, direction, and point of application. We also saw how a force can bring about changes in the objects on which it acts. We learned about balanced forces, unbalanced forces, and also about the net force. We found that force is a vector quantity because it can be described completely only when we describe its magnitude, its direction, and its point of application. So that's all for this video, and in our next video we shall discuss Galileo's experiment, his ideas about force and motion, and also the importance of Galileo's experiments, how it laid the path for the Newton's laws of motion. So if you liked my video, please like, share and subscribe, and we shall meet in our next video. Thanks for watching.